Good morning. This is Dave Kroll from Imagine That. Thank you for joining us again for another simulation masterclass. Today we have Scott Burry from Dow Chemical. Scott is a principal research scientist in the process optimization group. His research interests include process simulation and optimization of chemical processes using both continuous and discrete event technology and eliminating failure modes when implementing new process technology. He is a Six Sigma certified black belt. So if you have questions, feel free to type them into the questions box that's in your interface from GoToWebinar. And I think I'll just turn it over to Scott at this point. Thank you very much.
Thank you, Dave. Appreciate the opportunity to present what's sort of been a kind of a almost an ongoing development in terms of my thinking about how to be successful with simulations. And a lot of this has to do with the fact that we've been bringing on new people into our organization, and a lot of times, we're sending them off to go do good on and deliver on a project, and they'll run into barriers, they'll run into things that are going to prevent them from being successful. And so a lot of this has come out of numerous discussions and coaching sessions with people, as well as just trying to prevent frustration on my part when it comes to doing my own projects. And so I hope that you find this useful, and I do welcome any questions. We'll try to keep it brief and fairly organized today. So one of the things that you'll notice is going to be an overriding theme of this seminar is asking this question over and over again: what does success look like? And in particular, this is, you need to ask this of your clients. When you say you want a model from us, or you want me to work on this project, what does the successful outcome look like? And I have a good friend, and the way he would always ask this question is he says, imagine we meet up 5 years later, and we're reminiscing about how successfully, how wildly successful this project was, this simulation project was. And and so let's imagine what that was, and what were the key things that contributed to that. And there's this is a very common theme in terms of helping people try to reach objectives or reach an understanding of what they want to accomplish with a project. And I feel that it's very important when you're talking with clients about the simulation projects. With the increasing reliance on computer and increases in computer power, simulation technologies and things, it's almost become sort of a default fallback of, well, let's have somebody build a model. And I like to try to always emphasize, well, what do you want this model to tell you? Or what decision in particular do you want this model to help you make? And those are really, to me, the things that are the right step, the right first steps in any simulation project. Have to define success. So just a little more background about me so you can understand where I've developed this perspective from. I spent last 20 years in R&D at the Dow Chemical Company, and done many different applications of modeling and simulation tools, and have a pretty broad portfolio of observations about projects where simulation and modeling have provided a lot of value to the stakeholders, and ones that have provided frustration on both the stakeholder side as well as the modeler side. And So when I'm talking about the use of these simulation modeling tools, it goes well beyond just discrete event simulation, because we use models and simulation all the way from very detailed models about molecular simulation, all the way up to large enterprise scale optimization models. So for us, it's a very large investment and an important one. So being able to have get a good return on our investment in simulation and modeling technology is quite important. And I'm also very proud to work for Dow. And if you're interested in learning more about our company and how we're carrying out our business, and in particular on important issues about sustainability, water quality, etc., you can look at Dow.com. So to review what I promised in the abstract and what enticed you to sign up for this seminar, said that when you look at your clients, they really they have some problems, and depending on your company, they're defined as opportunities. But to them, that's really what's important. Is I have a problem and I want to solve it, and that the solving a problem is going to generate some form of value, and the value then can be defined as making the right decision at the right time to solve the problem. So if you are tasked with delivering data to make a decision that needs to be made on February 1st, and your model isn't ready until February 28th, it's no value. So you've missed it. So this brings in an important aspect of the time component, and it's also a very important one in terms of being successful, is to understand that time component and make sure that as you're managing your project that you are able to meet these time constraints. And from the standpoint of project management, unrealistic expectations or unrealistic time constraints are one of the key factors that are noted in the literature about project failure. So, not being able to deliver the model on time or on budget, constitutes a failure. So, you do yourself personally a disservice, as well as doing a disservice to your client, if you overpromise or you truly don't understand what it takes to deliver on your project. So this moving on to the third point here. The right decision requires the right data, and there's a lot written about decision making processes, what goes into decision making, what goes into understanding uncertainty, and it's very clear that one of the great benefits of doing either Monte Carlo type simulations or simulations of discrete event type things is that we get insight into systems that help us understand the impact of variability, the impact of choices and things. But that data that's provided from the model needs to be linked in a very smooth fashion into the decision making. And the sophistication of your clients is going to vary in terms of their comfort level with uncertainty, their comfort level with understanding statistical presentation of the data, etc. And there's a lot of good papers out there and a lot of good suggestions from very experienced modelers and simulators that can help you learn to craft and present your data in the right way. So this is something that is very key to delivering a successful product. And now moving on to what I think are some of the key aspects is that, it's not, it really goes beyond just your technical ability with a simulation or your technical ability to develop a very good model of a process. There's it's the soft skills at the front end of setting up a project and dealing with your clients that I think really will differentiate you from someone who just provides a service to someone who is in demand to provide a service to clients. And that's this idea of this front-end contracting and good project management. So, as I mentioned, there's a lot of good things already out in the literature. If you go to the winter simulation papers and you type in successful simulation, there's 2,400 results and tips for successful practice of simulation and how to conduct a successful simulation study by some extremely famous people and such. But when I read these papers, there's only been one that really talks about this time component, getting the right data for the right decision. And most of the time, there's an assumption that everything is laid out perfectly by the client, and it's sort of just like a standard textbook problem. You go and you organize your simulation project, and you build a conceptual model, and data is all available, and it's all in a good form, and you give the results and the presentation, and everybody's happy. But in general, my experience, that's not how it works. People are not as prepared to request a simulation project as they should be. So again, I'm going to go back to what I think are the key questions for you as a simulation provider or as a problem solver, being contracted to work on a problem, and that is, do you understand what the client means by what is success? What is necessary for success? What is the decision or decisions that they want to make? And what is the data required to make the decision? So I'm going to go into a little bit more detail about these later, but I'm going to make two comments here about project management and when not to simulate. So project management is another thing that is mentioned in a lot of these other papers that have been written on being successful with simulation projects. And my observation of people that are successful in technical careers, a lot of times the key differentiator is their ability to manage projects successfully, whether it's just themselves and their portfolio projects, or when they have other people working for them, or they're working within a larger team. So it's a valuable skill, and there's a lot of very good resources that are available, a lot of interesting insights about projects, as well as some very interesting stories, especially about software projects that fail. So I strongly encourage you to go out and invest in yourself and develop both your general project management as well as project leadership skills. They're complementary factors, but they're slightly different. And I like to avoid doing simulations if I can, primarily because they take time, and a lot of times with just a little thought and a little careful consideration, we can gain insight either from just traditional analytical analyses or reasoning about problems, and so that's why my emphasis on what is the data required to make the decision, and again, what are the decisions that are made are key, because if something is vaguely defined in the beginning, you may be off building what you think is the right simulation, but it has nothing really to do with what the true decision for the client is. So, even if you have successfully done that, sometimes it pays to say, well, I can answer this question just with either a simple insight of using a simple model, and that gives me the right information, because a lot of times a simple model is going to be a lot more tractable in terms of understanding behavior versus a complex model where you're not really sure what's going on. So begin with the end in mind, and this is has two parts. And the first is, what does success look like for the client? And this is a decision point. If they can't define it, then you need to walk away from the project. And otherwise, if they're willing to, you can help them define success. But if they give you some general thing and you feel, that it's too open-ended, or it begins to, or there's no clear stopping points, there's no clear decision criteria. There's a whole list of things that turn what should be a straightforward exercise, and it can be a complex problem, or it can be a difficult problem, it can be a hard problem to solve. But what you don't want it to do is you don't want it to turn into what's called a wicked problem. And the wicked problem was defined back in the 70s in relationship to the way that the government started to do problem solving. And what they discovered is that it's not a nice wrapped up thing because of these issues. There's not a clear decision criteria. There's not a clear way to address the problem. There's not a clear stopping point, and so on. And this can be analogous into simulation problems where somebody says, well, can you just sort of tell us the behavior of, or how many people are going to be waiting in line, or what's the throughput going to look like? Well, if they're leaving out a lot of information, if they're leaving out a lot of details about constraints, or a lot of details about what they're really trying to achieve with the simulation, that's a clear red flag that you need to consider. And I've added in this next topic about what does success look like for you, and this is again, because this is a webinar about development of your career, or your your skills as a problem solver. Understanding what's important to you and why you're either taking on this client or why you're taking on this type of problem is a very significant aspect of your own personal development, personal and professional development. And so I was listening to a webinar from the Stanford organization on decision making, and it was quite enlightening to hear them talk about that. Most people can only get on a first pass about 40% of what's really important to them in terms of key objectives and in carrying on an activity. And the activity that they were describing was MBA students, and they were looking at taking on a summer internship. And what struck me is from this data and from the study is that it's an iterative process to determine what are the key objectives, whether they're for yourself or what are the objectives from the client. And so, and keeping with this consistent theme of you need to always be asking your clients, what does success look like, and what do you need to get there? Because that's what's going to guide you for developing your simulation as well as the product that you're providing. And so the way that we've developed this little flow sheet is what we call front-end contracting, and this is what we bring to our clients internally when they're when they ask us to build a model, because that's the most common request that I get. I typically don't get a request to specifically answer a question. They say, we want to model this process, or we want to model to help us evaluate something. But the actual quantitative criteria is rarely mentioned, and so we start this loop, which can go on for quite a bit of time, where we just keep asking them, what is success? What are the constraints? What's needed? Then we go through and we say, okay, here's how we understand what you told us. We loop back through and we say, is this correct? Is this verified? Have we verified that we're meeting your needs? That we're on the right track. And if it's not quite, we loop through again. If it's aligned, then we can get on to actually defining what's needed in the project. And so this is where you start to get into the nuts and bolts of planning out a project. And an interesting perspective about projects is that what you're managing is a whole set of tasks. And it's much easier to plan out a series of tasks if you have a very clear, objective and very clear goals. And this is where developing your strengths in good project management, even if you're only managing yourself and you're the only resource on the project, it's invaluable in my opinion. And of course, we also have this third path, which is to cancel. And I try to have a fairly good quotient on canceling, because a lot of we really when we drive down, people want a model sometimes just to make themselves feel better, but they've either already made the decision, in which case they don't need any more data because they've already decided what the course of action is, and this can be extremely frustrating, because if the model comes back and shows something counter to what they had planned, they're not you're going to walk away frustrated, because you know that they're making a decision that's not supported by data. Now, if you're an independent contractor, you may not care as much, but since I'm an internal contractor and hence a stakeholder, I tend to care a little bit more about decisions when they're not supported by data. Now, what we found through executing this process is that when we don't do it, we have a lot more problems with our projects. And but when we do it, it does take a lot more time, even as we've gotten better at it. But when we have done it, it always has led to successful projects and much faster project execution. So while it may seem like a burden, and you're not getting in there putting blocks onto the ExtendSim screen right away, this will save you a lot of time and a lot of frustration. So just a few brief comments here on decision-making models. So I've talked about the emphasis on decision-making models. Different organizations have different or use different models. One that we've modified internally to use is based on the EPA's data quality objectives, and it's a rather elaborate 7-step process. State the problem, identify the decision, identify the inputs to the decision, that's the data, find the study boundaries, develop a decision rule, tolerable limits on errors, and optimize design. And you can get a fairly detailed PDF if you just search on EPA DQOs or data quality objectives. And we've modified this really to help us, get down to what I've been talking about, which is what's success, what's necessary for success, what's the data, what happens if you're wrong, what happens if you're right, and when do you need it by. So, again, it doesn't really matter of the many good decision-making models which ones that you use or that your organization uses. It's just important that you realize that it's the key starting point to the successful simulation. And again, I'm going to, as I continue to emphasize this, it's all defining, these topics right here. So I'm going to stop now. If you have any questions, I'm happy to entertain them. Otherwise, thank you for listening.
I do have a good question from Jack Kessler, and he says, often the client generates ideas from a simulation model we develop. Have you given any thought as to how one might capture these unanticipated benefits?
I guess in terms of I agree that's a very that is actually a fairly common experience, and but I think that that you actually have a better you have a better chance of achieving those or getting that sort of lagniappe if you've done all this work up front to define define the decisions that the project is initially trying to achieve. And I think that I think that it's not something that you plan for, but I don't really know what else to add to that.
Jack says, every time we develop a model, we wind up going back to the customer to force them to provide additional data. This often has a beneficial aspect on their system-level thinking, and that's true. At least in my experience, is one of the big benefits of simulation is that it forces you to look at a system in details that people haven't necessarily thought about before. It's easy to kind of wave your hand and say, well, we'll figure that out later, or this will just work. But when you really have to quantify things, that's a strong benefit. Do you have any comments on that, Scott?
I think that is also a common experience. I guess part of the reason that that we try that I've sort of almost become much more militant about demanding data up front or trying to demand clarity on the decision level and the detail is because it saves either rework or and it saves or it gets us to an endpoint faster. And as an example, where a colleague of mine who's not in our organization, but they do extensive amount of discrete event simulations. They were originally tasked with doing a model, and they were told, well, just develop it. We'll be happy with 80%. Sort of an 80% approximation. Well, that never got them to what they needed, and so a year later now, they're still working on refining and developing the model, and there's multiple demands on limited resources and things. So I think that had the modeler not just accepted the 80% criteria at the beginning and really challenged and said, okay, do you really understand what that means when you're saying, I just want this at an 80% level versus the higher level, that would have prevented that case. And sometimes you just don't know. So, but I will still fall back to having a clearly defined set of objectives in terms of what success is and what are the decisions that are trying, that your client is trying to make, sets you up much better to be able to respond to these surprises like, well, we're not really seeing this effect, or this assumption is not bearing out when we're doing the simulation.
That's what I have. I don't see any other questions. I'll wait just a moment. If anyone else has a question, feel free to type it in the question box. But thank you very much, Scott. This was a very good presentation. This will be recorded, or has been recorded, and we'll be posting it up on our website along with, I think Scott said you're going to supply the slides as well.
Yes, I'll provide the slides. I have a couple extra hyperlinks that I didn't quite get in yet that I'll update.
Once again, Scott, thank you very much. We hope to see everyone next month for our next masterclass. This and other recordings will be available online. Thank you very much.